What's up, everybody? Welcome back to another live stream from the Scalar Learning channel. And we are back to more SAT math content. First of all, sorry guys, it's been almost a week since we released our last video. It's because I was out of town in New Orleans and just had a lot of things going on this week as well. But we are back, and if you're here for SAT stuff, dope. If you're actually taking the ACT this Saturday, well, I got good news. We got a lot of good content coming out this week for ACT math. We got a critical concept videos that we're hopefully dropping by this Friday, and we're probably going to be doing a marathon this Friday. The marathon will be, I think, around 2 hours of just ACT content. So that's going to be on Friday. We're going to post that shortly in terms of when that's going to go down. We're just going to hit it hard for you guys preparing for this upcoming ACT. Anyways, without further ado, if you guys are here for SAT content. So we're going to roll through another mini test. What's up, Chris? And we are doing a time section calculator. So I got this queued up, and we're just going to have to jump right into it. And that's it. So here we go, ladies and gentlemen. We're going to start in 3, 2, 1. Let's do it. Okay. Whoops. Hold on. To make that extension. Oh, come on, bro. There we go. All right. We got our web paint thing up. Okay, given the parallelogram shown to the left, what is the value of x? So in parallelograms, opposite angles are congruent. So they're saying this whole thing is a parallelogram. And these sides are parallel. That means that's 72. That means that's 72, which means this is x as well. And then we can, but it doesn't matter because we got all the values in a triangle now. So 72 plus 60 is 132. And then this is triangle sum theorem. Everything adds up to 180. So it has to be 48. Boom, done. All right, next. The plot of the left YD plane shows a depth D in meters of volcanic lake exactly Y years after the date of the first recording. What is the significance of the point on the D axis? So D axis is here. So that's the depth. That means the depth was 225 at 0 years. What's the point? Plotted on the D axis. The depth was 225 at 0 years after the date of the first recording. So whatever. The depth of the lake, the maximum, the volcanic lake disappears to, no, what? Okay, I mean, it is this. It just doesn't say anything about 225. That is the max, the first recording. Yeah, so we're good there. Next, hold on. One of my lights went out. Let me just see if I can get it back in the zone here. There we go. Oh, nope. Hold on 1 second, guys. Come on. Stay on. All right, there we go. Sorry about that. A linguistics library contains several archives of language samples. The table above gives the number of distinct languages referenced in each archive. What is the range of numbers of distinct languages referenced? Okay, range is largest minus smallest. So 258 is the largest. Smallest is 3. So yeah, I mean, I literally think it's just, I'm hoping it's not overlooking something. Just feels too straightforward, but it should be 255 because that's range. 255, and I think that's it. All right. Li Jing has already read 1/3 of her 384-page book. I'm just that mentally that's 128 pages, right? So Li has done 128, right? She figures that she reads at a constant rate and can read about 45 pages in 1 hour. And if M is the amount of time in minutes, so let's say 45 pages in 60 minutes. So if M is the amount of time in minutes it takes Li Jing has spent reading the final 2/3 of the book. So she's already read 128. The final remaining is 256, right? 256. That Li Jing has spent reading the final 2/3 of the book, which is finding best approximate the number of pages she has left to read. So let me think about this for a second. So she's starting with 256. So that's out and that's out. Oh, sorry. That's out and that's out. So we know it's starting at 256 and then it's minus whatever. So it's not 45 minutes. It's not 45 pages per minute. It's 45 pages per hour. So this one is wrong because that means in 1 minute she would read 45 pages. That's wrong. But this one is in 1 minute she's reading 3/4 of a page. That makes sense because then in in an hour, when it's 60, you do 60 times 3/4, that is 45. So D clearly has to be the winner, and that's the equation. Boom, done. Okay, next. How much time do we have? 12 minutes. Uh-oh. What? No. What did I just click? Did I just close this? Okay. On Monday, Harry had 75% as many toys as Teddy did. So on Monday, Harry, Teddy. So if he has X, he has 0.75X. On Tuesday, after Harry acquired 32 more toys. 32. Oops, what am I doing? After Harry acquired 32 more toys. So it's adding 32 more toys. And Teddy acquired 15% more than he had on Monday. So that would be 1.15 times X, right? That's 15% more than his original. You add 1 to the 0.15. What's up, Viraj and NRG? Harry had as many toys as Teddy did, so now their toys are equal. How many toys did Harry have on Monday? So this is what we're eventually trying to solve for. So it's calculator, but I don't think we need it. So I'm going to minus 0.75x, minus 0.75x. Boom, boom. And we get 32 equals. So, sorry, let me just get a drink. So minus that is blah, blah, why am I blanking? 0.7, 0.4, right? 0.4x, and then we divide both sides by 0.4, divide both sides by 0.4, boom. And that's obviously 80. Because it's like 4 gets into 32 8 times, so it's 0.4, so it's 80. But that's not my final answer. I need 0.75 or 3/4 of 80, which is 60. Now I'm going to think it through and make sure these numbers make sense. That means if Harry has 60, he had 80, he gains 32, that's 92. He gains 15% of 80, which is 8 and 4, which is 12. Yep, 92, so it works. All right, that's just a quick mental check, plugging things back in. We're good to go. 60, here we go. Consider the following systems of equations, blank, blank. The solution of the system of equations are the points 0, 3, 0, 3, and 5, 0. Oh, because that's quadratic. And 5, 0. What is the value of k? So how can we do this? Let me think here. What's a fast way to do it? Obviously, 5 is one of the y-intercepts. Probably the other one is like, oh, it's going down. No, what? It doesn't make any sense. Oh, I get it. It's going to probably go like this is what it is. So I'm just estimating, right? It's probably, so k is probably negative 3/5. I'll bet you. Just from the look of this and from what I'm creating. Now, I'm going to test it out. So if I have x minus 5, x minus 3/5, that would mean if I plug in 0, I'd get 3, right? I already know if I plug in 5, I get 0. So 0 plug in 3. So now I plug in 0 for x. That's negative 5, because 0 minus 5 is negative 5, times negative 3/5. Look at that. Negative 3/5 times negative 5 is 3. Boom, done. Verified. So that was using a little bit of like looking at the graph and then plugging and chugging and all that. Taking the International ACM Friday, so you don't mind. Yeah, so the critical concept, I'm going to do my best to meme. I will try, and I got to shoot it still, but it will be up by Friday at the latest. Oh, but you're taking it on Friday. Okay, I will do my best. I'll try tonight to work on it. Maybe I can record it tonight, edit it tomorrow, okay? The concession stand at a football game sells hot dogs and drinks. 2 hot dogs and, okay, so let's say hot dogs is X, drinks are Y. So 2x plus 4y equals 8. If it costs $7 for 3 hot dogs and 2 drinks, so 3 hot dogs and 2 drinks is 7. So you see it's a system of equations. Like I already know, and then we need to find the cost for 1 hot dog and 1 drink. Now, this is interesting because, okay, well anyways, let's just use elimination. I'm going to multiply the bottom one by negative 2, and I get negative 6x minus 4y equals negative 14. So I'm going to add this with this. So 2 plus negative 6x is negative 4x. So I'm kind of ignoring this. That adds to that, which is 0. And then negative 14 plus 8 is negative 6. And then we divide both sides by negative 4. X equals 6/4, which is 3 halves, which is $1.50. So a hot dog is $1.50. Now I plug into either equation. So if a hot dog is $1.50, that's 3. 2 times 150 is 3 plus 4y equals 8. So I minus 3 from both sides. 4y equals 5. Divide by 4, y equals 5/4, which is 1.25. So the two together are 275C. Explaining to us, I'm struggling to dominate math, but I need a reading improvement. Math is better than reading. NRG. Oh, I'm glad it's helping. Thanks for your help. Yeah, that's nice, Alex. Good luck. Oh my God, I'm so scared for the March 12th again. Wait, I'm taking it in March 2, guys. Just FYI, I'm signed up for an official one. On a 40-degree day, 25 mile per hour wind creates a wind chill of 29 degrees. So 25 miles per hour creates wind chill of 29. To approximate wind chill at various temperatures caused by 25 miles per hour, Elon used the following rule. Take 24 less than 4/3 of the air temperature. So you see, I literally translated that on the dime, right? So what it would be here is we plug 40 in for the air temperature. X is air temp. And then 4/3 of 40 is 160 over 3, which is 53.3 minus 24 is about 29. Yeah, so that's the formula works there. Okay, if a 25 mile per hour wind creates a wind chill of -5 degrees, which is the air temperature. Got it. So then this equals the wind chill. So we got a wind chill of, see, it's just plug and chug equation, right? That's why equations are so helpful. Now we can add 24 to both sides, add 24 to both sides. 19 equals 4/3 x, and then multiply both sides by 3/4, multiply both sides by 3/4, boom, boom, like this. And then 3 times 19 is 57 over 4. I'll use a calculator here. 57 divided by 4 is 14.25, which is 14.3. Boom, done. And that makes sense, right? It should be above. Shouldn't be below, right? Should be above. Okay, 2 more. 5 minutes. The value of VM in dollar in particular house M months after. Let's go back here. Okay. The value of VM in dollars of a particular house M months after purchase follows the equation given above, where M is a positive integer. Following statements best describes the value of the house over time. Oh my God, what's happening? Wait. So the value of the house, and then this is the value of the house. So this is like 2 months. So what you do is, so this is the value of a house, let's say in 2 months, and then this would be 1 month after purchase. So there's always a difference of 622, and I think it's dropping linearly. This is a weird question. I've never seen a question quite like this. So I'm trying to wrap my head around it. Because if we plug in 2 for M, it would be V of 2 minus V of 1. Basically, the difference from the second month to the first month is 622. And then if I plug in 3 and 2, it's V of 3 minus V of 2, which means, again, the difference with each subsequent month is always 622. That's linear. So the value of the house is increasing linearly because every subsequent month it's 622 more than the previous month. So I think that's right. It's a little strange, but we'll see. A donut franchise has determined that its average cost per donut, AX, is given by the function above, blah, 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 where X is the number of units produced and X is greater than 0. Which of the following best describes what happens to the average cost per donut? Average cost per donut is the number of units produced. Happens to average cost of donut as the number of donuts produced increases. So it's basically like as it goes to infinity. I think what we're doing here is this is almost like an infinity situation. So it's like if this goes to infinity, it's almost like a limit question. Basically the 20,000 kind of goes away, and it basically becomes 0.15x over x, which means it gets closer and closer, and x cancels out. It gets closer and closer to 15 cents. Because we're talking about increases like to huge amounts, right? That 20,000 is massively significant. But imagine if you produce like 1 million donuts or 100 million or 1 billion, then that 20,000 is kind of like nothing, right? Because 0.15 times 1 billion is 150 million. So the 20,000 kind of go away. So we're talking about getting closer and closer to 15 cents. So it's not going to it will never equal it exactly, but it'll get really close. All right. I think we're good. I'm not going to use the extra time. I'm just going to submit. Come on. Yeah, legend. All correct. Okay, let me see some of these comments. Yeah, Tamim, you're welcome. Okay, I'm going to try really hard. I've got a lot of stuff going down this week. But I promise you I will do my best. I didn't know people were taking it Friday. Can you do an ACT reading? I don't do ACT readings. I just do ACT math. Are these questions generally harder than the ones you see on the SAT? Yeah, Oh, I mean, like, they're pretty good. They're reasonably accurate. But, like, the last two that we just did, harder for sure. Yeah. Can I get a scholarship with a 1,300 score? It depends. So here, I made a video. I'm going to send it to you right now. It's called Everything You Need to Know About the SAT. So if you want to see some possible scholarship stuff, there's a section in this video on scholarships. Let me send it to you here. And I believe the scholarship stuff is, here it is. It's right around here. So these are like some examples of scholarships. So like, see, at Colorado State University, you could get 5 Gs just for like scoring in that range. But again, it has to be with the SAT GPA. Here, a 1320 gets you a 15 grand at like Florida Gulf Coast. So it just depends. I think there's other ones too. Or no, those are just some ones. Yeah, I just kind of like picked some random ones that I found publicly posted. And in SAT reading. Hey, what's up, Yarn? Okay, guys, I hope you enjoyed that, and I hope that was helpful. If it was, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining. Don't forget, ACT Math are coming tomorrow and Friday. I'm doing a marathon Friday, so if you're around Friday, it'll be around this time. We're hitting it hard Friday, at least 2 hours, okay? Thank you guys so much for joining, and I will see you in the next video. Take it easy.